We're going to review the differences between truly and repeating continuous defects. Truly continuous defects are those running without interruption for more than 3 feet or 1 meter. A repeating continuous defect is that defect that occurs at several joints along the pipeline segment. The rule for this type of continuous defect says that at least 3 out of 4 joints, or 75%, should be affected by the defect in order to qualify as a continuous defect. Let's see some examples of how these two defects look in a real scenario. The following video shows residues of grease attached to the pipe wall after the pipe has been cleaned with jetting equipment. Now note that more than 3 feet of the pipe is affected, and therefore this is a truly continuous defect. The following video shows roots coming into a pipe at the joints. Now note that the roots affect more than 75% of the joints observed, or 3 out of 4 sequential joints. The structural defects family is organized into the following groups: crack, fracture, broken, hole, deformed, collapse, joint, surface damage, lining failures, weld failure, point repair, and brickwork. A crack is represented by the letter C and describes a visible break line on the surface of the pipe, which will have pieces of the pipe still in place and not visibly open. A fracture is represented by the letter F. A fracture is an advanced stage of a crack where the pieces of the pipe are noticeably open. The broken group, which is represented with the letter B, refers to pieces of the pipe displaced and not in their original position. Hole is used to describe when pieces of the pipe are missing, leaving the soil visible or a hole visible. The deformed code is represented by the letter D and can be used when the distortion of a pipe wall in rigid pipes is up to 40% of the cross-sectional area. Collapse follows the natural deterioration progression in rigid pipes. Collapses are represented by a letter X. The deformation of the pipe walls must be greater than 40% of the cross-sectional area. The joint group of codes is represented by the letter J. It is used to record abnormal displacements at pipe joints. The joint group has 3 different codes, JA, JS, and JO, for angular, separated, and offset, which should not be used in conjunction with the joint column in the details section of the CCTV form. The codes related to surface damage follow the normal H2S attack progression, beginning with roughness increased to missing wall. Surface spalling, corrosion, and others are additional defect codes within this group. In most cases, surface damage is caused by general degradation in concrete pipes, such as degradation caused by erosion or hydrogen sulfide attack. See 3 examples of surface damage at the top of this slide. From left to right: surface aggregate projecting, surface reinforcement projecting, and surface spalling. Buckling is a newly added structural defect group in PACP. It refers to deformations and other defects without loss of visible structural integrity in flexible pipes, such as corrugated metal pipe, PVC, polyethylene or PE, plastic, and other flexible pipes. Under normal circumstances, flexible pipes are expected to deflect, allowing interaction with the soil. However, excessive deflection and other surface damages on flexible pipes are signs of structural distress. On the right side of this slide, you're looking at 3 different types of buckling defects in PACP: KW, or buckling wall, KD, buckling dimpling, and KI, or buckling inverse curvature. Defects in lined sewers are recorded using the lining defects code in the structural defects family. Defects such as discoloration, shifts, overcuts, undercuts, delamination, and others can be coded. For these codes, remember that the host pipe is defined as the pipe as originally constructed. See some examples of a buckled lining, a blistered lining, and an overcut surface at the bottom of this slide. Weld failure defect group is used to record defects of the weld or seam in the pipe fabric. These defects can occur on large diameter plastic spirally wound welded pipes, butt fused pipes, or metallic pipes. Point repairs, or RP, are used to record where part of the pipeline has been repaired or replaced. The codes are applicable to localized pipeliners, patch repairs, and others. Brickwork is used to record areas of the sewer wall where bricks or mortar is missing, or where the sewer invert is dropped. The following video shows a fracture hinge 3 defect. As you can see, the pipe presents fractures at 12 o'clock, 3 o'clock, and 6 o'clock. This type of defect is coded as shown in the video. In this video, the operator is focusing on an offset joint. Finally, this video shows a surface damage aggregate projecting, or SAP defect. Note that this defect should be considered truly continuous. The operation and maintenance family is organized into the following groups: deposits, roots, infiltration, obstacles and obstructions, vermin, and grout test and seal. Deposits cause blockages and reductions in hydraulic capacity. The deposits group in PACP is divided into DS for deposits settled, DA for deposits attached, and DN for deposits ingressed. The images shown on top show a deposit attached incrustation, a deposit settled gravel, and a deposit attached grease. The roots group of codes is used to record the various type of roots found inside a sewer. Roots often intrude through the defects along the pipe wall. Where there is a structural defect that enables a root entry, as in the case of a fractured pipe or a defective break-in tap, separate entries for both the structural defect and the roots should be made. Roots can be further classified in fine, tap, medium, and ball. Infiltration is another operation and maintenance defect group. It refers to the ingress of groundwater through sewers through the defects or porous areas. As with roots, it is often used in conjunction with other defect codes. However, the defect is not visible or significant enough to code only the infiltration. The infiltration group includes 5 descriptors: stain, weeper, dripper, runner, and gusher. The images on the left show different types of infiltration, such as IG for gusher, IR for runner, and IS for stain. This group is used to record large and medium-sized obstacles in relation to the cross-sectional area of the pipe. These types of objects often prevent or limit the continuation of the survey and reduce hydraulic capacity. Note that the small-sized objects should be coded in the deposits group, as we had discussed earlier. The images presented here show construction debris, or OBN, other obstacles, or OBZ, and pipe material in the invert, OBM.